Admit the last person. All right, welcome. I'm Ryan Holger with TEC. Today we're going to do thermostat basics. This is an ongoing series of training that the folks have set up primarily for the people in the stores. So Rob and Kathy and those guys set these up. So I'm going to tackle thermostats this week. Somebody else has a different topic next week, and so on. I'm going to do this a little bit different than probably thermostat presentations you've seen in the past, where some vendor goes through all their products and all the features and how wonderful they are and all that good stuff. I'm going to attack it more from a function of what is this thermostat supposed to do, or what is a thermostat supposed to do? How do you wire these up? Because my feeling is once you know how to wire them, it's very easy to make sure you pick the right one. If you do not know how to wire them, you have no clue. You're reading some manufacturer pamphlet trying to decide if it will work on your piece of equipment. I've never looked at that. I always go right to the wiring diagram, and from there I can decide if I'm going to use it on this widget or not. So that's the way I'm going to show it to you guys today. All right, so obviously the thermostat's job in life is to turn on the heating and cooling equipment and to turn it back off again. I think you probably already know that. And as mentioned, I'm going to attack that from a wiring standpoint, at least initially here. So a normal thermostat wires the same. For every single thermostat that you probably ever see in your life, it all wires the same. Of course, there's always going to be exceptions to the rule, right? Um, this red line that I drew here, everything above that is the back of a thermostat, and everything below that is the mechanical equipment, so the furnace and air conditioner in this particular case. The designations on thermostats are standardized for the most part between various pieces of equipment, or between various brands of thermostats, rather. So you can see in this case, we have an RC and an RH. R means red. Specifically, it's the color red. That's why it's labeled R. And that doesn't mean you have to use a red wire, but unless you're a savage, stick with the color coding. All right, so that means it's the red wire. The reason you have an RC and an RH is because you can have a separate red for cooling and a separate red for heating. That is not common. You normally just have one red wire, and that wire's job in life is to provide 24-volt power to the thermostat from the furnace or whatever piece of equipment you have. That's the job of that wire. All right. The next wire that you're going to have is going to be historically W, or in our case, W1 on this drawing. By the way, this drawing is off an Ecobee stat, but it's the same for pretty much everything. So W or W1, if it's a two-stage stat, then it'll list W1 and W2 separately. If it's a single-stage stat, it usually just says W. So that's W for white. So the color is the labeling of the letter on the stat again. And the job of the W wire is for heat function. That's the job. So that wire is utilized to energize heat. So a thermostat, and that's horrific writing. A thermostat functions as a switch, right? So the light switch you have on your wall that turns your lights on and off, what that switch does is it interrupts one of the wires that power your lights, or it reconnects it when you put the light switch on. That's all it does is it breaks the wire and reconnects the wire, breaks the wire, reconnects the wire. The thermostats can do the exact same thing. So internal to the thermostat, there's going to be a connection that goes from, where's my little laser thing? I'll just do the pen thing. That's going to connect R back into the white. That's what it does. So when the thermostat would like to have heat for the space, it closes an electrical connection internal to it between R, which is power, and W. That allows that 24 volts essentially to leave the furnace on R, go through the thermostat, and then come back to the furnace on W. And if that furnace sees a complete electrical circuit because the switch has been made, it energizes the heat, or in this case, gas furnace. It could also be electric heater, hot water valve, boiler, or something else, right? So that's how that would function. And it's going to be the same for everything, for heating, cooling, fan, etc. That's how those are going to work. Let me see if I can clear any of those off. We'll just leave it on there. If I clear it, it'll clear all of it. The next wire in discussion is going to be G, which is green, as you might guess, based on the letter. That wire's job in life is to turn the fan on. And it works exactly the same way. 24 volts leaves the furnace circuit board, goes up into the thermostat on R. If the thermostat wants the fan on, it connects R to G, and sends that same 24 volts back down to the furnace on G. And when the furnace sees a complete electrical circuit, it's like, oh, yeah, I got it. You want to run the fan. No problem. I got it, right? Admit these people. All right. So that's the main ones there. Heat, fan. The next one on the docket is going to be the yellow wire, labeled Y. Once again, if you have two stages, it'll be Y1 and Y2. If you just have one stage, it'll just be Y. And the job of the Y wire is cooling. And it works the same way. It's a switch, right? Now, there's a couple things different here. One, the white wire is usually white, the green wire is usually green, the red wire is usually red. The yellow wire is like 50% of the time yellow. The other half of the time it's blue. And that's just a function of who bought the cable when they did the installation. Historically, it was always yellow, and then somewhere along the line, somebody thought it'd be a good idea to use blue for cooling because it seems like a snowflake, blue, I guess. I don't know. So you get a lot of installations that have red, green, white, and blue, right? The color of the actual wire doesn't matter in real life. It's the electrical connection that matters, but color coding it makes it easier for everybody. But historically, that would be the yellow wire. The other thing that's different about this one is that the G and the W went back to the furnace only. The cooling wire, the Y wire, goes back to the furnace, and then it goes out and extends to the outdoor unit, the air conditioner in this case. So it does two different jobs. Now, the order you wire it in doesn't really matter. If you wanted to wire Y from the thermostat to the air conditioner, like drop the wire out the window, run it to the air conditioner, and then into the furnace, you could do that. It would make no sense because you're already running wire from the thermostat to the furnace. But you could wire it in any order you want. And technically, you could wire from Y to the outdoor unit and never even connect it to the furnace. The furnace does not need to know that there is a call for cooling. The furnace needs to know that there's a call for the fan on the G signal, and the thermostat will energize the G whenever it energizes the Y. However, in modern furnaces, we do like to have the Y take a pit stop at the furnace because we like to have different airflow speeds set up for heating versus cooling. And the only way the furnace knows to use the cooling airflow speed instead of the heating airflow speed is when it sees that the thermostat has requested Y. And then it's like, oh, okay, you asked for Y, you want cooling. Oh, you want 800 CFM instead of 930 CFM that I would have done for heat, or whatever the numbers happen to be. That makes sense so far? If there's any questions that come up, if you could either ask them or type them in that little chat box. If you don't want to ask them out loud, that's fine too. And I will try to address them as we go. I realize I got a sloppy mess of stuff going on here, so I'm going to clear it off. All right, so that takes care of R, G, Y or Y1, and W. The Y2 and the W2 are optional, which is why it's shown with dotted lines, and those would only be utilized if you had two stages. So if you had two stages of heat, then you'd have a Y1, or excuse me, a W1 and a W2. If you had two stages of cooling, you'd have a Y1 and a Y2, and those would connect over to the furnace as well. And in the case of cooling, it would have to extend to the outside. So for two stages of cooling, you need three wires to go outside instead of two. There's ways to kind of bastardize that and get around it a little bit, but fundamentally, three wires go outside when you have two stages of cooling. So that takes care of W2 and Y2. All right, I'm going to save the PEK for later, like in 5 minutes, we'll address that. The accessories, this happens to be an Ecobee stat that I'm looking at, but all the thermostats are fundamentally the same. Some thermostats will have accessory terminals like Ecobee. Some will call them auxiliary terminals like Venstar does. I think Honeywell calls it S1 and S2, I think it is. They all have some of those names, and those are flexible terminals, and you could use them for different things, right? W's for W, Y's for Y, G's for G, right? But the accessory or auxiliary terminals can be used for flexible things. So maybe you want to use it to turn on a humidifier or a dehumidifier, or open up a ventilation damper, or turn on an ERV, or make a light bulb flash on, or whatever weird thing you want to do. So there's all kinds of things that those can do. Because the opportunities are fundamentally endless, I'm going to skip that discussion for today as well. We're going to focus on regular core thermostat here. I'm also going to take a pass on the OB terminal for now. I'm going to save that for about 20 minutes from now, and we'll address that. That is for a heat pump, and we'll talk about that in a little bit. Right now, I have on here, it says conventional system. When we say it's a conventional system from the perspective of a thermostat, what that really means is That means gas furnace. It means propane furnace. It means oil furnace. It means electric resistance heat in an air handler. It means anything that is not a heat pump. There's really only two choices. There's conventional and there's heat pump. Those are the only two things. So anything that's not a heat pump automatically becomes a conventional system, and it wires the way that I've been describing to you thus far. I guess we already talked about, well, RC and RH. I started telling you there's a R for cooling and an R for heating. Most times you only have the one R wire, like I mentioned. R means the red, means the 24 volts coming from the transformer. And usually you only have one transformer, and that's sitting in the furnace. And even if your air conditioner has its own transformer, that's usually for a different function, and it's not for the low voltage thermostat circuit. So you still only have one transformer, and that's the one in the furnace. There are times you will have two transformers, and you can never have two transformers on the same circuit, but you will have two transformers that you're trying to put on the same circuit. And that'll be if you have a boiler, which has its own transformer always, and you have a cooling system, which has its own transformer, and you want them to be on the same thermostat. So then you have to separate them into R, 24 volts for heating, and R, 24 volts for cooling, and not let the streams cross, just like in the Ghostbusters movies, right? So I'll show you one drawing on that later on as well. And that leads us to the final one, which is C. And that one, unlike the other ones where the letter designates a color, green, yellow, white, red, C designates the job of the wire, not the color. The job of that is common. So for all circuits, you have basically a hot and a common. Hot is R in this case, common is C. So for whatever reason, it doesn't get labeled based on color, probably because when we started using the common wire, at that point, there was no standard for color. There was whatever wire is left in the cable that you haven't used yet. So there is really no standard for it. I personally like to make it black whenever I can, but that's not a standard at all. Not all thermostats have a common. If the thermostat is mechanical in nature and how it operates, it does not have or need a common. So common mechanical ones, if you take the cover off a stat and you see like a metal swirling spiral like that, we call that a bimetal stat. Bimetal meaning more than one metal. When metal heats up or cools down, when it heats up, it expands. When it cools down, it contracts. So as the room gets warmer, that bimetal spiral, if you will, starts expanding, and that causes the edge of it to click and touch an electrical connection and complete a connection. So as the room warms up, the metal expands and completes an electrical connection, and then the thermostat knows it's supposed to be turning cooling on, and as it contracts, it completes a different electrical connection, and it knows it's supposed to put heating on. There's no power needed for that. I mean, there's power from the furnace to the stat and back, but there's no power to operate the stat. The stat is just a switch. Just like the switch on your wall doesn't need power to operate. It's just there, and the power is your hand, right? You don't need actual power to make the switch function. The same thing with electromechanical stat. Or you could have a mercury stat, right, which is a very common way we used to do it as well. And the mercury would slide through there and complete a connection. That also does not require any type of power source to operate the stat itself. So in those cases, you don't have a common. But as soon as the stat needs power, then I need the common wire, the fifth wire added into the discussion. So if the stat has an LCD display, or if it has a circuit board or microprocessor in it, or a Wi-Fi chip, as soon as I have one of those things, the stat's going to need power, and I'm going to need an extra wire on here. So the normal scenario, which is R, G, Y, and W, we typically call that a four-wire thermostat. And that's like what we use from like, I don't know, 1960 to 1990 or something like that. And then once we started using stats that are more fun and have more features and screens and computer chips in them and all that good stuff, then we need to add the common wire. So that would make it a five-wire stat. And that's not a big deal. It's one more wire, like no problem, right? But sometimes when you're retrofitting an existing system, you're taking out their old boring stat and you're putting in a new stat. That stat needs a fifth wire and you don't have it. You only have four in the wall. So then you either need to pull new wire to the thermostat, which most people don't want to do, or you have to use an adapter to trick it essentially. And that's what we'll talk about next. While we're on this screen, any questions on here about the basic wiring? R, G, Y, W, common, those five? I guess 5 to 7 because W2 and Y2 are pretty easy to think about. So far, so good? Okay. All right, let's say you need the 5 wires because you're going to put in an Ecobee or a Nest or a Honeywell T6 or whatever the cool stat of the day happens to be. And you don't have enough wires. There are some things you can do. So we have some wiring adapters that can be purchased as an accessory to convert 4 wires into 5 without buying a 5th wire, essentially. All right, so this one happens to be the one for Ecobee. Ecobee calls it a power extender kit, PEK. The PEK only works on Ecobee stats. It does not work on any other brand of stat. Ecobee and Ecobee only. The other brands have their own tricks, which I'll talk about, but this one's only for Ecobee. So what happens is you have the thermostat on the left here, and you have a furnace down here on the right, and this is the wall, in between them, or if it was just this wall, then I guess you'd pull in the wire. But usually it's a wall 30 feet down a rabbit hole, left turn, right turn, further or this way through another wall, and then into the basement, right? And pulling new wire becomes hard then. So you have 4 wires that you own in the wall, and you want them to do 5 jobs. You get this PEK kit, which for years came with the Ecobee Stat standard, like it was included automatically. But in more recent times, it is not always included. Sometimes it is, sometimes it isn't. Specifically, it is not included with Bryant and Carrier IntelliSense Ecobee stats. So Ecobee makes some of the thermostats for Carrier and Bryant. The ones that are IntelliSense, which are all the current ones, do not come with a PEK in the box. And the reason being is the PEK will cause the IntelliSense features to be disabled. IntelliSense is what allows an Ecobee stat to communicate to an IntelliSense furnace and IntelliSense outdoor unit. And the way it does that is by communicating through the Y and C wires. And the reason it's Y and C is because those are the only 2 wires that connect to all 3 widgets, meaning thermostat, outdoor unit, and indoor unit. So it uses Y and C for communication. Once I show you how this PEK wires, you're going to see that I'm going to lose my Y wire, and hence I will not be able to use it for IntelliSense, and hence that will disable it. So because of that reason, Bryant and Carrier stopped including the PEKs in the box. The thermostats from Bryant and Carrier can still use a PEK, but you either have to use one that you have laying around, because a lot of contractors have them laying around because when they came in the box, you only needed it half the time. So half the time you got them sitting on a shelf in your shop. You can still use those, or they can buy one from us, TEC, if they want one, they need one. But they just have to know it will disable the IntelliSense, but it will function completely normal in terms of HVAC control, traditionally speaking. All right, the way the box works, it's got 4 wires on one side, 5 on the other side. So on my thermostat, I have R and I have W, and those go down through the wall, go over to the box that gets installed inside the furnace. There's a little magnet so you can stick it on there, and those pass through basically untouched. They just go through there, and everything's normal and everything's fine. Right? Those ones are normal. What's not normal is the other 2 wires. So what used to be the common or used to be the green wire gets moved and repurposed as the common wire. So you can see, I don't know if you can see, the green wire is on my common terminal of the thermostat. And then what used to be the Y1 wire gets repurposed as the PEK wire, and that wire is in fact yellow in this case. So I lose my G and Y, and I essentially combine them into one single wire called the PEK wire, and that frees up a wire for me to put on the common, which I desperately needed. So now PEK essentially means cooling and fan. Those 2 commands travel over a digital signal through the wall on one wire to that box. And that box's job in life is to then split them back into 2 signals, specifically Y and G. That's what that thing is going to do. So inside this box, there are 2 relays. And the furnace, it doesn't know any better. The furnace over here thinks that box, in terms of fan and cooling commands, is its thermostat. It doesn't know. The thermostat's sending a message to the box, and the box is closing the relays. So once again, G and Y get merged together into the PEK wire, and that frees up a wire to then be used as the common wire. The trick to this, or the hard part, is that the way this box is labeled is to make it easy for a homeowner, which thereby accidentally makes it hard for an HVAC tech. And the reason ecobee does that is because the vast majority of ecobee stats, in fact, the vast majority of thermostats in general are now installed directly by a homeowner. It's something like 80 some percent of thermostats are installed by a homeowner. Whereas when I started here in the 90s, it was the opposite. Like 80 some percent of thermostats were installed by an HVAC professional, and homeowners hardly ever did this themselves. Now it's the other way around. So they made it easy for them. And for them, it means the red wire goes to R, the green wire goes to green, the yellow wire goes to yellow, the white wire goes to W, voila. But an HVAC contractor knows that he put this green wire on common. So when he goes downstairs to look for the green wire, he wants to land the green wire on common, but there is no common. And then he's like, what the hell? What's going on? And then he knows he used the yellow wire for PEK. So when he walks downstairs, he's looking for somewhere to land a yellow wire that's labeled PEK, but that doesn't exist. So the HVAC pro in his mind has to know that G on this box actually means C, and that Y on this box actually means PEK. Other than that, it's pretty straightforward. So once you do one, you kind of got it. I don't see any questions coming in so far. If you're just joining me, if you have a question, ask it verbally or type it in the chat box and I will read it. All right, PK only works with ecobee. Honeywell has a similar widget that works almost exactly the same way, and Honeywell only works with Honeywell. So you can't put Honeywell on ecobee, you can't put ecobee on Honeywell, or any other brands for that matter. Honeywell is only for Honeywell, ecobee is only for ecobee. And if you were not aware, Honeywell sold their business, their residential HVAC business, they sold it to Resideo, and they gave them like a 50-year licensing agreement of the name to continue calling it Honeywell Home if they wish. Commercial is different. Commercial is still Honeywell, but residential is all Resideo. So if you're looking for the manuals and information on this stuff, do not go to the Honeywell website. There'll be stuff on there, but it'll be more homeowner orientated, and they do have different model numbers of things for homeowners very often if homeowners are going to buy direct. You want to go to the Resideo website because that's going to be the exact products that we utilize here at TEC and any distributor of HVAC would be utilizing. It works very similar. The thermostat reuses 4 wires that are in the wall, and instead of going to an ecobee PEK, it goes to a Honeywell C adapter box, and that sits down in the furnace. It's got a little magnet just like the ecobee one, sits in the furnace, and away you go. It wires basically the same way. By that I mean the red wire is a straight pass-through, the W wire is a straight pass-through, and then on the thermostat, the G and Y wire do not get used, and those 2 wires then get repurposed as a common. So the green wire leaves the fan terminal on the stat and instead gets connected to the common. So when you go down at the box, G goes to common, right? And in this case, at least Honeywell labeled it right. They didn't do it the weird way for homeowners like ecobee did. And then the other wire that you had gets put on the K terminal, which is very similar to an ecobee PEK terminal, on the K terminal, and that K terminal's job is to combine the fan and cooling into one signal. And when you bring it downstairs to the furnace, it goes to K. So yellow goes to K, green goes to common. So it works fundamentally the same way that the ecobee one does. They speak a little bit different language, so you can't swap them around and use one and the other one, but fundamentally they work the same. All right. So ecobee only works with ecobee, Honeywell only works with Honeywell, but there are other ones as well. There is a Ventstar add-a-wire kit, which we have had here at TEC. Well, when I started here in the 90s, we already had it. We only been using Ventstar since 2008, I want to say. But prior to that, Ventstar used to manufacture some of the Carrier products. So they manufacture some of the thermostats, like if you've ever seen like the Debonair stats, the 33CS stats, right, and some of the accessories. They also made this thing called Add-A-Wire back then, and they still make it. It just doesn't say Carrier on the label. It says Ventstar. The one I have in my hand says Total Line, which, as you guys know, is a Carrier brand. This is one I've just been dragging around in my bag for 20-some years. And the nice thing about the Ventstar version of this is it works with anything. So you can use the Ventstar Add-A-Wire with Ventstar. You can use the Ventstar Add-A-Wire with Honeywell. You can use the Ventstar Add-A-Wire with ecobee, with Nest, with any brand of stat that you want. It doesn't matter. So ecobee PK only works on ecobee. Honeywell C-Wire only works on Honeywell, but Ventstar Add-A-Wire works on all of them, anything that you want. And the reason being is on the Honeywell and the ecobee, there's a special terminal on the stat labeled PEK or K that only works with those brands. With Ventstar, there's no special thermostat or special thermostat terminals. Instead, there's two things. There's the box that goes down at the furnace, and then they give you this little widget. This widget is 2 wires in, 1 wire out, and there's a diode in between them. So if you look at the drawing that I have here, it's 4 wires in the wall that somebody owns, and I needed to do 5 wires worth of work. So our wire is a straight pass-through, just goes right to the furnace like normal. The W wire is a straight pass-through, goes through like normal. And then I have my G and Y. I take one of those wires and I make it into my common. So I switch it to C on the thermostat and I put it at C at the piece of equipment as well. And then that leaves me 1 wire left in the wall, in this case the blue wire, to do 2 jobs. Those 2 jobs are fan and cooling, green and yellow. So I wire green and yellow to the thermostat on one end, tuck that behind the thermostat, and then the blue wire connects to whatever wire I have left in the wall, and that goes downstairs to the little box. The box separates that back from blue back into 2 wires. And there's 2 relays in here, just like there was on the Honeywell and Ecobee things. The reason for the extra 2 wires down here is to power the box. So it works exactly the same as the other 2, except it can be used on any thermostat. We've been using these for 20 plus years. Half of our dealers use them with regularity. They know how these work for the most part. The other thing that's different, other than you can use it on any stat, is you can use it on anything of the stat. So for Ecobee and Honeywell, you can only combine cooling and fan into 1 wire. But for this, I can combine any signals that I want. So let's say, for example, I do have 5 wires in the wall and I have a 5 wire stat and everything's great. And then I decide to upgrade this to a 2-stage gas furnace. And now I need a 6th wire, which is W2. What I can do is I can take W1 and W2 and wire it to the thermostat on these 2, and then run this through the wall and separate it back later. So essentially take the W wire and split it into W1 and W2. Or I can any other wire that I want. The only rule is I can't split one of the power wires, which means that R and C have to be dedicated and not have this widget on there. Any other signal wire I can split. I can split fan, I can split cooling, I can split cooling 2, I can split heating, I can split heating 2, I can split the humidifier wire, I can split a accessory thing, or I can split anything I want except for R and C. And because of that, you can actually buy 2 of these boxes and put them on the exact same furnace. So let's say you had 5 wires in the wall, but now for heat, cool, fan, hot and common, but now you wanted to switch over to 2-stage heat and 2-stage cool, and you were short 2 wires. Obviously, you can run new cable. That's an option, but sometimes it's hard depending on the walls. So you could get 2 of these and use one of these to combine the 2 heat signals, and then use a different one to combine the 2 cooling signals if you wanted to. Obviously, at some point, like you're buying a lot of widgets, you're buying, 2 $25 boxes, and it might be cheaper to run wire at some point. Good so far? Questions? All right, those are the 3 that we sell. Sometimes we also sell, but not usually, but sometimes we do have these fast stats. And even if we don't sell them, many distributors do. So some guys are familiar with them. It fundamentally works the same way. This one happens to be the fast stat 1000. For the scenario that I'm talking about, getting from 4 wires to 5 wires, you could also use a 5000 or you could use a common maker from fast stat. But basically it works the same way as the Ventstar thing. It's different, but it's similar. You get a little box that goes behind the stat. You get another box that goes at the furnace. The one by the stat's job in life is to combine some of the signals into 1 wire, and the box by the furnace is supposed to split them back again. So it basically works the same way. Just another widget to do it. And some contractors standardize on this one because they've been using it for decades. All right, heat pumps. So heat pumps are different. I said everything before was conventional, which means fossil fuel stuff as well as electric resistance stuff. But a heat pump is different. So when I have a heat pump wiring, once again, the stuff on the top is the thermostat and the stuff on the bottom is the equipment. So I got an air handler furnace on the bottom right, and I have a heat pump on the bottom left. So some stuff's the same. I still got R, I still got G, I still got Y, I still got W, I still got common. I still got those 5 wires. But now I need a 6th wire, and that is the OB wire. The OB wire, his job is for the heat pump reversing valve. That's what that guy does. It's labeled as OB because historically it was either an orange wire or it was a blue wire, and those 2 things meant something specific. The O and B used to be on old thermostats. You'd have an O terminal and a B terminal, and you have to pick the right one to wire to. and I'll explain what the difference is. On a modern thermostat from any of our vendors, it's O/B. They are combined into one because you would never need both at the exact same moment. They are combined into one, and then electronically we tell it which one we really want. Electronically means from the keypad or with a dip switch or a jumper or something behind the circuit board, something that says I want an O or something that says I want a B instead. The difference is that you have to know what your heat pump wants. So what a heat pump is, fundamentally, for those who don't know, like your air conditioner at home, there's an evaporator coil sitting above the furnace, and his job in life is to absorb heat from inside the building. And then there's a condenser coil sitting outside, and his job in life is to reject heat out of the building. That's what those two things do. What a heat pump does is it swaps the evaporator and condenser coil. Now, it doesn't physically move them because that would be ridiculous, but it swaps their jobs. And the indoor coil sitting above your furnace literally becomes a condenser coil for the compressor. And the outdoor coil becomes the evaporative coil, right? That means I'm now absorbing heat from outside and I'm rejecting it on the coil on the inside, and that's hence how we're heating the building. So in order to run the heat pump, the compressor has to turn on. The wire that turns on compressors is Y, or Y1 in our case here. That turns on the compressor. So if a thermostat wants to run cooling, it's going to turn on Y. If it wants to run heating, it's also going to turn on Y. So how does the outdoor heat pump know, well, did you mean Y cooling or did you mean Y heating? Like, why, what am I doing here? Right? So it has to be told which one you want, heating or cooling. And that's the OB terminal. And that tells the reversing valve which way to go. What the reversing valve does is instead of the hot gas leaving the compressor and going to the condenser coil, the reversing valve redirects it. And when the hot gas comes off the compressor, it sends it to the indoor coil. Basically just flows everything the opposite way through the system. So the reversing valve and or the heat pump have to be told when to energize. And the reason why you have two choices, O or B, is because some manufacturers default their heat pump to run in heat, and you have to tell it to switch to cooling. And other manufacturers default their heat pump to cooling, and then you, the thermostat, have to tell it when to switch to heating. They do it differently. So for brands that you're familiar with, Carrier, Bryant, ICP, Train, American Standard, Lennox, those type of brands are defaulted to heat. If you energize Y on a heat pump, the heat will run. And if you want cooling, you have to energize Y plus the reversing valve, the OB wire. Other brands do it the other way. For example, Rheem, Gree, Florida Heat Pump, most Asian manufacturers, what they do is they default to cooling. So if you energize Y, the heat pump assumes you want cooling, and if you want heat, you have to energize Y plus the reversing valve. So long story short, from a thermostat standpoint, I need to have a thermostat that can control a heat pump, and I need an extra wire from the thermostat downstairs that I didn't have previously. Additionally, there's some extra things that you have to do between the furnace and air handler, or furnace or air handler, put an F down here for furnace, and the outdoor unit. So running wires outside, I still have C like I had before on a cooling only system, and I still have Y. And then if I happen to have a two-stage system, I'd also have a Y2. Right? But for right now, let's keep it a single stage. I have C and Y, but you see I also have three other wires here. I have to have the OB wire. That's not an option. I need a third wire going outside. Now in this drawing, it's showing the OB wire going to the furnace and then back out to the outdoor unit. That's usually not the case because usually the furnace doesn't have an OB terminal because the furnace doesn't care if you're running heating or cooling on the heat pump. It doesn't matter. The furnace just wants to know, do you want me to turn the gas on? Do you want me to turn the fan on? Do you want me to go to cooling airflow speed? That's all I really care about. So it doesn't need the OB, so that terminal's not usually there. So that wire comes downstairs, and then usually it just wire nuts to the wire going outside and never actually terminates at the furnace. So I need those three wires. So I need more wires outside. And then additionally, in most cases, you're also going to want to wire R on the outdoor unit, which we've not had done before. And then what I have on here is W2, sometimes just labeled as W, sometimes labeled as D for defrost. What that does is it allows the heat pump to energize the indoor heating system, meaning gas furnace or electric resistance heat, when it's in defrost mode. So as I said before, the evaporator and condenser coil switch jobs. And in the summertime, your evaporator coil sitting above your furnace has condensate on it, water draining off the coil and going into the pan. Well, when all of a sudden the outdoor coil is the condenser coil, the evaporator coil, it'll also have water forming on it. And if I form water on the coil outside and it's below 32 degrees, that's obviously going to freeze. and then I'm not going to be able to run any airflow through there anymore. So heat pumps all have what's called a defrost cycle. The defrost cycle thaws the coil outside. And the way it thaws the coil outside is by switching back to cooling mode temporarily. And then what that does is absorbs heat from the indoor air and uses that to thaw the coil outside. And it thaws it really quick. It's nice, but it does mean I'm running in cooling mode, which means the air coming out of the diffuser above Mrs. Jones' head at her house is going to be cold air, and she's not going to be happy about that. So her thermostat's asking for heat, and she's getting cold air blowing on her, 55-degree air. So heat pump manufacturers know that, so when they go into defrost, they close an electrical contact on the heat pump between W and R, or maybe it's D for defrost and R. And what that does is it completes an electrical circuit at the furnace. The furnace doesn't know this isn't a thermostat. Over here at the thermostat, when something connected R to W, it said, oh, okay, you want heat. Well, now something's connecting R to W. Oh, okay, you want heat. It just has a second thermostat. It doesn't know you have two thermostats, and one of them's built into the heat pump. So that causes the indoor furnace or air handler to turn on its gas heat or its electric heat to temper that air back up. So instead of 55-degree air blowing on someone, now you have 110-degree air or whatever temperature air you have. So in reality, if you're going to install a heat pump, especially in the Midwest or above, you're going to want to have a minimum of 5 wires going outside to the heat pump. And you might as well just go ahead and pull 6. That way you're covered in case somebody upgrades to a 2-stage. In general, anytime in life that you're going to pull wire from point A to point B, pull more wire than you need. Because then later on, if a wire is damaged or you want to add something, you're good to go. The amount of cost of the extra wire is minimal compared to the amount of effort of doing it twice. But you need 5 wires going outside. So that is not often that you have that. Usually around here meaning the Midwest, we typically have 2 wires outside, Y and C. And if it was a more modern, efficient system, we might have 3, Y1, Y2, and C. But we're never going to have 5 wires sitting there waiting for us. So we're going to have to run new wire. If you don't want to run new wire, you have some choices. You can use a communicating system, which we're not going to cover today. It's a whole separate thing, but you can use like ion evolution infinity controls, and you never need more wires in those cases. But if we stick on thermostats, today's topic, then my only choice is to pull new wire, or I can get another kit type thing. So that same FastStat company makes this kit. They call it the Model 9000. It comes with 2 boxes like this. One box gets installed outside at the heat pump. One box gets installed inside at the furnace. The thermostat wires come down to the furnace, and they go into this box and then also go ahead and relay out to the furnace. But once that box sees all the things that it asked for, oh, you asked for heat, or you asked for cooling, or you asked for blah, 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 it summarizes all of those. And if there's any calls for reversing valve or for compressor, it sends those to the outside on the 2 wires that you already own. In this case, they're orange and red, but they could be any color you want. And that goes to the other box that's sitting outside. And that box takes those 2 signal wires in and divides them back up into all their individual jobs. In addition, if the heat pump calls for defrost, meaning that it energizes W and R connection, this box will receive that and send that message back on the red and orange wire to the indoor box to say, hey, the guys outside want the heat to kick on for defrost, man. Can you hook that up? And then the indoor box turns it on. So everything's happening over these 2 wires that between the 2 boxes where they're communicating to each other. And inside the boxes, there's just relays that are actually doing the switching, but they're communicating in between them. So that does save the effort of pulling new wire. I should caution you, and I just sent an email last night on this to the salespeople, as well as the management team for the parts stores that they'll probably eventually communicate to you guys once they digest it. You probably don't want to try to use these on any of the new refrigerants, the A2L refrigerants. The reason being is there's an extra widget you got to install anyway, the dissipation control board, and it's not clear if it's going to be able to work with the dissipation board. And even if you could bastardize it and get it to work, it's going to be pretty challenging for a field tech to figure out how to wire all these weird widgets together. So I'm recommending you do not use this on new stuff. However, if they have a 410A system, we've been using these for 20 years. Even though he's only been selling them for like 2 years, we've been using them, buying them from someone else and using them for a long time prior to that. So they work pretty well on R22 and R410A heat pumps, but I would avoid their usage on R454B and R32. If you need short wires there and you were short wires between the thermostat and the indoor unit, They have another box called the 7000. I do not know why the 7000 box does more stuff than the 9, but the 7 does more than the 9, and the 7 costs more money because it does more stuff. Basically, you have two similar boxes. They do the same thing I just described. Plus, there's a smaller little box that gets installed behind the thermostat to allow you to use 4 wires in the wall to get all this thermostat signaling down to the other box. So you could utilize that if you want. Questions? Anything you want to ask out loud or type in? If not, I will keep talking. If something comes up, just let me know. From a boiler perspective, I mentioned that there are times that you would have two transformers, one inside the cooling system equipment, the air handler or whatever you have, and one inside the boiler. And you cannot have two transformers in the same circuit. It's like two beta fish in a tank. One will attack and kill the other. You can only have one. So some thermostats have an RC and an RH on them separately, and it allows you to keep the cold side cold and the hot side hot, like the old McDonald's commercial, if you're elderly like me. So RH, which is the 24-volt red hot wire for heating, and W would go to the boiler in this case. I know they're showing a second wire for a two-stage boiler, but that barely exists. You're never going to see one. So it's pretty much R and W on the thermostat going to, and actually on the boiler, you're not going to see R and W either. You're going to see TT. TT means thermostat. That's what you're going to see on there. But that would be for the boiler side of the equation. And then inside the thermostat, there's a separation of church and state. And there's another electrical circuit that has nothing to do with the boiler, where I have my cooling command, my fan command, and I have another 24-volt power source from that transformer, as well as the common. I guess I shouldn't have drew the line. The line's confusing now. And the common all go to the cooling system, if you will. So you could do that. Many stats have that, not just Ecobee like I'm showing here. Venstar has models that can do this. Honeywell has models that can do this. There are different ones. Sometimes you might just have a boiler, meaning you do not own a cooling system. Maybe it's an older building, especially buildings like, 1945 and earlier would typically not have been designed with, well, they definitely would not have been designed with cooling and maybe never added, or maybe they have window units or ductless units or something that's not involving the thermostat. So the thermostat is a heating only thermostat. Boilers need 2 wires in order to operate. They need R and W, or like I said before, most boiler manufacturers label them T and T. But most thermostats, if you're going to get a cool thermostat, meaning a display, a Wi-Fi chip, a microprocessor, anything like that, you need a common wire as well, like I stated previously. So you will need 3 wires down to that boiler. You won't have that. You'll only have 2 because no one ever thought that there would ever be a reason for a third wire back in 1945. So you will only have 2 wires, and you'll need to pull a third wire in order to get the cool thermostat to power. Cool meaning whatever your favorite brand of stat is. If you are not able to pull a third wire, or it is very expensive and difficult based on its location, there are ways around that. All of the ways are dumb, except, well, running a new wire is good, but except running a new wire, all the ways are dumb, except the FastStat Common Maker. You can utilize this device. It's another product from FastStat. We do have that in our system if somebody needs one of these. It has 2 boxes, a big one and a little one. The big one goes down by the boiler. The little one goes behind the thermostat. And what it does is it changes 2 wires into 3 wires. If you recall, I said we cannot do that with the Venstar add a wire, right? And those kind of things, because this little device can only combine signal wires, meaning heat, cool, fan type commands. It cannot be used on R or C. Well, if I need R and C for the stat, that's 2 wires. And if I only have 2 wires, I'm done. There's nowhere else to put this. So I cannot use an add a wire to make a 2-wire into a 3. I can make a 3 into a 4. I can make a 4 into a 5. I can make a 10 into an 11, but I can't go from 2 to 3. But this product can do it. And the way that it works is it combines AC and DC voltage at the same time. So if you're not aware, AC voltage travels right through the metal of the copper wire. DC voltage travels on the outside of the metal. Therefore, you can have an AC and a DC signal traveling on the same piece of metal at the exact same time and not really interfering with each other. And that's what this box does. It takes the white wire, which is an AC wire, and it converts it into a DC signal. And then it has the common, which is an AC wire, pass through as AC. So got AC here and AC here, but this box combines them together, and this white wire gets converted to a communicating DC signal. So this part right here is AC and DC. Then the box separates it back out into their individual jobs. It has power going on the common, and then it has the heat command going on the white wire. That's all that thing does. All right. No, I don't want to keep that. All right. I'm going to show you a couple things on some of the websites just so you're aware. Once again, if there's any questions on anything I've showed previously or that I'm about to show, just blurt it out and ask. I think you guys should probably see on my screen, I have the Vendstar page on here right now. I'm not going to go through all the products with you because I'm sure everybody else has already done that with you, the reps and so forth. I do want to point a few things out. Um, so on the top of the Vendstar page, if you hover over thermostats, it shows you all the thermostats that they have. The ones on the bottom here, what I'm going to call like the legacy stats, we've had the first three on the bottom we've had since the 1990s. This other one on the bottom right is slightly newer, but not much newer. And they've been around forever. People know how to use them. They either like them or they don't like them. If they're their favorite stat, great, keep using it. If not, no worries. The ones on the top are a little bit newer, and some of them are not even that new. Like the Color Touch is like, I don't know, 15 years old at this point. Um, and it was so cool at the time, like, oh, I could put a screensaver photo on it and all that. But in reality, it's a thermostat, right? Um, and each one of these has multiple models doing multiple things. The one that I specifically want to point out to you right now is the Explorer. When I click on that one, specifically the Explorer T4900, because that is our high volume stat. Probably not from your perspective at the store, but as a company, it's our high volume stat. And the reason being is it's the only Vendstar stat that complies with the energy code that we have. And this would be energy code for Illinois, Wisconsin, Minnesota, and Michigan. Indiana, Kansas, and Missouri, your code is so old you don't need this. Although individual towns have newer codes where you live, but the statewide code, if it exists, does not require that. So this is the only one from Ventstar that's code compliant. By the way, Honeywell's only got 3 or 4 models that are code compliant. Ecobee has 0. Like, it's not easy to be code compliant on this. But because it is code compliant and because it is the least expensive code compliant stat that we have at TEC is the one that we quote with every rooftop, and hence a lot of people get those. When you scroll down on this or any other stat, I got residential models here, I got commercial models. When you click on one of those, it gives you a little chart showing you what things it can do and so forth. The thing I should caution about, whether it's here or whether you're going to see me point out some stuff on Honeywell in a minute, like this says 2 heat, 2 cool. And then right below it, it says 4 heat, 2 cool. And you're like, what the hell, dude? Like, is it 2 stages of heat or is it 4 stages of heat? Like, it can't be both, man, right? Well, it can be. And that's because usually when manufacturers say it's 4 heat, 2 cool, they're referring to a heat pump. It can do 2 stages of heating with the heat pump and then 2 more stages of heating with your electric or gas heat. It cannot do 4 stages of gas heat typically, right? So that's how they're labeling that on those, and that does get confusing at times. The other thing on their site here, if you click on accessories, it'll show you different accessories that are applicable to the stat that you're looking at right now. And then the install manuals and the product literature manuals are on here. So if I go to the T4900, which like I said is the most common one we use, there's like a sales product data type sheet, and then there's the install manual if you needed to download those things. Just wanted to point that out on there. If you're using Honeywell products, as I mentioned earlier, don't go to the Honeywell site, go to the Resideo site, because that is residential Honeywell for professionals. So that'll be the same model numbers and stuff that you're used to seeing. And just likewise, you hover over products and it shows all their stuff. And in this discussion, we would go to the thermostat section and pick the one that we wanted. Oh, I didn't mention with the class this morning, but I should mention with you guys. We're assuming everything in this discussion today is a 24-volt thermostat. There are thermostats that are not 24 volts. I mentioned there's communicating ones, and that's a separate discussion. But there's also ones that are non-communicating and also not 24 volts. They're called line voltage thermostats, and they are either 120 or 240 volt thermostats. These are not common. You will not see these at someone's house controlling their furnace and AC. But where you will see them is maybe like in an apartment complex controlling a fan coil, or maybe like on some electric resistance baseboard heaters or something in a building, right? Something like that. And you cannot put 24 volt stats on line voltage applications and vice versa. There's ways with relays to creatively wire them and make it work, but you can't just straight up put them on there. So I should have mentioned that with the folks this morning. But anyways, you click on thermostats and it brings up all the various thermostats, etc., that you'd expect to see, like any other, decent website, right? What you will want to get from Honeywell, for those of you that work with Honeywell, oh crap, I closed it on accident. I had the PDF open and then I just closed it. That was a mistake on my part. Where's my download folder? While I'm taking 12 seconds to figure out what the heck I did, why don't you go ahead and type in a question to make it more fun for me and take all the pressure off me staring at my screen reloading. And nobody typed a question in. That's okay because I got the screen ready. All right. So Honeywell over the years puts out these thermostat charts. They do change every couple of years when new stuff comes out. Some of you may have them as like a placemat at your counter or something like that. I'm going to zoom in on the left right now. The only bad thing about these is they're so giant. So it's hard to see them on a computer and definitely hard to see them on a phone. But down the left-hand side, they'll tell you like what kind of category of stuff this is. So like the T10 stats are what they're calling their new Red Link type protocol. They got their Wi-Fi stats, their old legacy Red Link stuff, right? There's a Z-Wave stat on here, which we seldom ever use a Z-Wave stat. Z-Wave stats are ones to tie into certain automation systems, like a home automation system that speaks Z-Wave. Basically, it's a T6 as far as the HVAC guy is concerned, but instead of having a Wi-Fi chip, it has a Z-Wave communicating wireless protocol chip. All right, and then you got the regular basic stats on here too. All right, so these charts are pretty helpful. There's a couple things I want to point out specifically. One, as mentioned, just like other manufacturers, if it says that it's 4 heat, 2 cool, that doesn't mean it's 4 stages of gas heat. Not that you typically need that anyway, but when they say 4 heat, 2 cool, they mean 4 stages of heat pump. Actually, they mean 2 stages of heat pump and 2 stages of electric heat combined together. That's how you get to 4. Honeywell is at least pretty nice in that they tell you what it is as a heat pump and what it is as conventional as a separate statement. And once again, conventional is every single thing that is not a heat pump. You want to connect it to a water valve, a boiler, a gas furnace, an oil burner, or whatever, that's conventional. Anything that's not a heat pump. So I'll point that out on there. The other thing I want to point out is that not every stat it works with a heat pump. We're getting to the point where almost all of these does, but I can find one on this Honeywell list that does not work with a heat pump. And this is a weird stat. I'm sure it's a hydronic application stat or something. But if you're going to use a heat pump, you have to make sure the stat does heat pump. Additionally, if you are going to use a heat pump and a gas furnace at the exact same time on the same system, you need what is called a dual fuel thermostat. And for whatever reason, whoever at Honeywell made this chart put dual, D-U-E-L. It's D-U-A-L, dual meaning two, not dual meaning fight to the death. But I like to point that out because it's fun. And I don't get a lot of fun in HVAC over here. So a dual fuel stat means it can handle 2 fuel sources, meaning gas heat and heat pump. In order to have a dual fuel stat, you must have an outdoor air temperature reading. You cannot have dual fuel with outdoor air temperature. What a dual fuel stat does is it looks at the outdoor air temperature, and when it gets below a certain temperature, whatever the installer has selected, say for this example, 49 degrees. If it's below 49 degrees, gas furnace. If it's above 49 degrees, heat pump. There's a cutoff point. If you're curious about how the cutoff points work or how they should work, we have a 12-minute recorded video on how to calculate those if somebody's interested. So you have to have a dual fuel stat if you're going to have a dual fuel application, and you have to have an outdoor air temperature sensor. In the case of Ecobee, they don't make outdoor air temperature sensors. They get the outdoor air temperature sensing from the internet broadcast. So Ecobee used on dual fuel must be connected to the internet, or you will not be able to use it in that application. So they can't be like, oh, I like the Ecobee stat, but I don't want anybody hacking into my stat. Like, well, then you can't use the stat, right? You have to make it so it's online to get the outdoor air temperature. Whereas Honeywell typically does it with a physical sensor. So I got that dual fuel column over here, and then there should be one here if I can find it that has on the far right over here wireless outdoor sensor and wired outdoor sensor. So I got dual fuel. Oops. And then over here, I got wireless and wired outdoor air sensors. And some thermostats can do either or. Some thermostats can do one. You'll see there's thermostats that, right here, no dual fuel, but it does have an outdoor air temperature sensor. Just because it has an outdoor air sensor doesn't mean it's dual fuel. It may have the outside air sensor for other reasons. So every outdoor air sensor thermostat is not dual fuel, but every dual fuel must have an outdoor air sensor. What else do we need to point out on here? Questions? Anybody want to ask anything? Okay, I'm gonna leave it open for a little bit in case somebody does have a question. Um, and I have recorded this as well. So if you got a coworker who missed it this morning and this afternoon, they were off today or whatever, um, then you can send them the recorded link. It'll be on our YouTube channel as well. I'm going to stay online for a minute or two in case somebody is slowly pecking away with two fingers typing their question. And you can also unmute yourself and just ask the question if you want. But I'll hang out for a minute or two. Otherwise, we are wrapped up.
Thanks, Ryan.
No problem, Rob. My pleasure, man. Not seeing any other questions come in, so I think I'm going to go ahead and kill it, guys. If something else does come up, just hunt me down. All right, thanks.